Good morning, everyone, and welcome to today's Industry Insight webinar, Securing Remote Access with Zero Trust by Genians Brett Hamill, VP of Technical Services.
Thank you, Sunny, and thank you, everyone from MISA. Pleasure to be with all of you again. We have the pleasure here at Genians of doing business with several MISA members, so it's always great to communicate with this community, both about challenges and maybe different solutions to those challenges, but also to get feedback from the community on those topics. So we really appreciate your time today. Today, we're talking about securing remote access. This is really the one topic that just keeps coming up and up over and over again. And a lot of it has to do, obviously, with COVID and working remotely. But I don't think really everyone is where they need to be yet, because we keep hearing questions about it. So as our products and solutions evolve, with the landscape of remote access challenges, we always like to provide updates with that to give insight about how we can address some of those challenges. So that's how we chose the topic today. For those of you with webinar fatigue, we have a fairly short webinar for you today. We only have around 12 slides. That and tomorrow's Friday, so I'm sure we'll get through this no problem. And with that being said, I'll go ahead and get started. So let's take a moment and examine what kind of factors are actually affecting remote access as we used to understand it historically. Obviously, the one really that goes without saying, but is still the primary driver, COVID-19, work from anywhere, and even post COVID-19, where everyone's looking at what their businesses look like after. There's just a massive amount that are selecting hybrid models. So having a few people or a particular department that used to connect in remotely obviously is no longer the case. So the amount of things that people can access and how they access them and where those resources are some of the biggest challenges. We have a couple of statistics here, both from Upwork and Owl Labs, but at this point, what we're looking at, 30% of the workforce is remote, right? And of course, day by day, week by week, that changes depending on the company. But as you probably all guess, that's likely to be a permanent factor in the workforce. 22% said they will be working remotely through 2025. So this is not a short-term thing. It needs to be part of the new model. And we're going to talk about why the long-term solutions need to change a little bit from what we're accustomed to in the past. Out of 10,000 employees interviewed, they pretty much said, hey, I'm just as productive from home as I am when I'm in the office. So there's obviously a strong feeling there. And then 32% of those surveyed indicate that they would essentially go find another job if they were not able to continue it. So it's a huge shift in the paradigm, which appears to be permanent. And then, of course, cloud adoption also affects remote access, really not because of where the person is sitting, but what they're trying to access. And what they're trying to access may not be in the on-prem network. So traditional VPNs could be problematic. A little bit more detail on cloud adoption, how it can affect remote access. So obviously it's increasing all the time. And we're actually to the point now where, if smaller companies, SMEs out there are getting rid of computer rooms or, makeshift data centers, or even large corporations, that essentially means less physical office space. And many companies are deciding, we're just going to go remote because of that. So less office space means more remote workers. Gartner is predicting 397 billion in cloud services this year. So that is indicative of how much is actually shifting to the cloud. It's in full swing at this point. So the solutions you have in place have to be able to accommodate that. And from the conversations that I have with with peers, customers, and potential customers is really they're not 100% prepared for that yet, or are still trying to figure out what best final solutions can be used to address that. Then the type of clouds, right? So you've got multi-cloud, hybrid, multiple cloud service providers. You know, some people have very strong reasons to go with Azure because they're all in with Microsoft. Others prefer AWS because of the functionality there. And obviously, there's a bunch of other cloud service providers out there. So just like with previous security solutions, if you're tied to one particular provider too tightly, and this also applies to the cloud, just like it does with an on-prem enterprise network, you get tied into one vendor too tightly, sometimes that could be problematic. So multiple cloud service providers is something that really needs to be taken into account when you're looking at any kind of security solution. And then traditional VPNs really are just not proving sufficient for this new model, either because of the amount of remote workers and the load, or a bunch of other factors we're going to talk about in a minute. But obviously, cloud adoption has a huge impact on whether or not you can use your legacy VPN solution. So let's examine a couple of different traditional VPN limitations. So we'll look at the IPsec VPN limitations. These can be very costly. You've got a server and endpoint licensing, upgrades, management. You have to do maintenance on the server. You have to install and deploy clients and maintain all of that. Also, historically, what we found is with traditional IPsec VPNs, the way they're configured is, you've got subnets that are actually considered routable over that connection and accessible on the internal network for remote connected clients. And sometimes that remote worker may only need access to a single application on a single server inside of that network. But because of how they're typically configured without too much configuration, they're going to have way too much access than they really need. So if you've gone to the trouble of trying to actually reduce access and do least privilege for people while they're in the office, and if they're remote, now they have way more access, that's problematic. So typically the way they're configured, by default, most of these IPsec VPN configurations do not follow the zero trust model. Also, a huge issue is with this cloud adoption is they typically don't control access to cloud resources. So if I'm sitting in Starbucks and I'm accessing a cloud application, I don't go through the typical on-prem VPN. So that's another limitation. SSL also has some limitations there because typically that is for web-enabled applications only. So if you need to SSH inside to a server or access something, if you're a developer, then you're going to be limited with an SSL VPN. Also, when you take away the client, now you really don't have the means to validate the security posture of that remote user's device that's connecting. So while from a cost and management perspective, it's advantageous because you don't have to worry about as much management and potentially licensing costs and configuration and deployment as you do with an IPsec VPN that has a server and a client. You also don't have the client, so you lose some capability there, including posture check, which is extremely important. And same thing here. Typically, that VPN gateway is stood up, in the on-prem enterprise network, so it's really not applicable for accessing those cloud resources. So all these traditional VPN limitations are why many people are exploring what other kinds of solutions are out there for these partially, hybrid environments where half of your resources are in the cloud, half are on-prem, etc. There has to be a better way. When you look at the Genian ZTna Cloud Gateway, it really addresses a lot of the issues that we just talked about. So first and foremost, you want to have the ability to have that client on the endpoint. The client is important because the client can actually perform a posture check before allowing a device to connect to the network. So all the security policies that you have when someone is in the office of having to have their OS updates up to snuff, antivirus up to date, running, whatever other special applications or prohibited applications that cannot be running, that actually all has to be validated before access to internal or cloud hosted resources should be provided. So having the client is actually important. So being able to do the authentication validation, obviously that happens with just about any VPN solution. However, the method of that authentication does matter. So and then finally, of course, the location of the individual. So if they're um, again sitting in Starbucks accessing a cloud application, you have to be able to address that. So the key is you need to be able to put your server or your gateway that's actually allowing device traffic in your internal network or to your, whether it be cloud or on-prem, that has to be deployable anywhere to match your environment. So it's not as simple as just taking a VPN appliance and putting it somewhere, right? It needs to be more portable than that. So you need to be able to work from anywhere, and you need to be able to deploy it anywhere. Those are two key factors that really are going to address a lot of these challenges. Some of the advantages that this provides, we talked a minute ago about pricing. So you have pricing sometimes of your VPN server client can be pretty costly. So a subscription pricing model is a great advantage to have. Also, having something that is completely cloud managed, configured, and with upgrades included, um, delivered as a SaaS solution, that's a huge advantage to take the burden off of your staff, and also ultimately gives you better ROI on that product. Built-in monitoring, redundancy, and backups. That's what you get with a SaaS solution, and that's why a SaaS solution is great for meeting these kinds of challenges. The client provides secure connection and posture check. So instead of just having, an old NAC client where it would, you know, typically be used for on-prem, and then a separate VPN client, having a ZTna client that just does everything, that provides the secure connection to your gateway, no matter where it's hosted, and at the same time does a posture check to make sure the endpoint meets all of your security policies before it connects. Those are the advantages of having a ZTna client. Multi-factor authentication, such as Windows Hello and FIDO, so basically biometric authentication. That way, you don't have to worry about the constant risk of passwords getting compromised. We're hearing now about password lists just basically being sold on the dark web. It doesn't even matter, if you're trying to educate your users to use strong passwords. If the entire password list gets compromised or sold, you still have the same problem. So there's going to be more and more of a push to shift to biometric authentication. So your solution should definitely include that. And always on option. So what this can do is it can make sure that all of the traffic is being protected and analyzed, and routed through your gateway. And that allows all the traffic to be filtered applicably, and also for you to be able to apply policies that are very granular. And having that traffic pass through a gateway is really what you want to be able to make sure that you've got full compliance. So an always on option will do that. Having the ability to do a real-time quarantine if a device fails out of compliance is very important. Just because you're sitting remotely doesn't mean that all of those same security policies should not apply. They, of course, do, and also should be real-time implemented. And with remote users connecting, sometimes that can be a challenge. Again, we talked about being able to control access to on-prem and cloud resources. I just talked to a customer the other day that it basically has half and half. They have no plans actually to going full cloud, but definitely did a big shift to cloud. So they need a solution that can do both. The policies really, in this type of a solution, mirror the zero trust model. So, in other words, we talked earlier about a legacy IPsec VPN giving access to entire internal subnet. Um, what you really want to do is follow the zero trust model. It doesn't matter if your users are remote. And what that means is least privilege access. So if I don't require access to an entire internal subnet, I shouldn't have it. If I don't require access to all applications on a specific internal server, I shouldn't have it. So even whitelisting a single IP is really not sufficient. It's really what specific applications do I need? And that's the only thing I should have access to when I am remotely connected to the network. Being able to implement URL filtering as well as application level control is another key feature. And whether you're using a URL whitelist or whether you're saying at the application level, you can't run Facebook, whatever your particular rule is, you have to be able to have those two features in to be able to make the most of your security policies for your remote workers. And the last two, network traffic analysis and network detection and response, the reason these are key is because it allows you to actually keep an eye on what kind of traffic is coming from that endpoint. So something malicious could be coming from that endpoint. It could be something that the user is doing. It could be something the user is not aware of. But being able to see that traffic in real time because it's going through a gateway, and then being able to respond to it from a security policy perspective is very important. And that allows you to ensure that post connection, once someone is authenticated, they're still following all the appropriate policies and that nothing's been compromised on the endpoint. So this is sort of what this process looks like. We talked about the different components. So of course you've got your ZTna client. What's happening there on the endpoint is you've got the biometric multi-factor authentication that's taking place. You've also got a posture check that's going to happen on the endpoint before it's allowed to have access. And then, of course, you're going to have the client that provides a secure connection to the gateway. So that's what happens on the endpoint. The gateway itself is going to have multiple things that it's doing when this connection takes place. Of course, it's going to process the authentication and allow the IPsec connection to take place. But in addition to that, it's actually going to do a few things immediately after authentication. One is to actually check the policies that would be applicable to that user device. Two, it's going to have an optional web filter enabled. So while it's going through the cloud gateway, because remember, we have an always on configuration here, which means all traffic from the user is going through the gateway. You don't want to have any kind of split tunneling where half of their traffic is going out their ISP and the other half is going through your corporate network or to your cloud resources. So you're going to be able to do a web filter feature to be able to filter out any URLs you don't want them to access. And then we talked a minute ago about network traffic analysis. That's what the traffic analyzer is for, to be able to look at all that traffic that's coming through and respond accordingly if there's something that would make it fall out of policy. Once all of these things have taken place, then the zero trust policy is assigned. That's going to, based on the user and the node or their endpoint and their status and all the different criteria that you can configure as granular as possible, then there'll be determination made on what internal resource that user device can get to. So whether they're trying to go to a website, whether they're trying to get the files, whether they're trying to connect to a database or get to a virtual or physical server farm, those zero trust policies will ensure they're only getting access to what they need to. And then, of course, you have to have real time monitoring. Once you actually go through all this, you need to make sure that if anything changes on that endpoint that would change what policy they actually have access to, then that needs to be monitored in real time. And you can respond accordingly, preferably pre-configured and automatic, so there's no administrator intervention in that process. So let's take a look at a couple of you know particular common scenarios that could be something that might be a use case that you may be looking at in your organization. So first, we want to do the posture check. Well, if the posture check fails, then right then and there should be no connection through to the internal network. So this is why an SSL VPN or something that's clientless really doesn't have this feature. So this is very important. Obviously, the same would hold true for your MFA if that failed. But the main point here is you're not going to be able to establish a successful connection and get past the gateway if you, in fact, don't pass your posture check. That's one of the most important. Certainly don't want to overlook that when you're planning a solution for remote access. Another example would be, let's say you've authenticated properly, and then you're trying to get to an unauthorized URL. So that is where the web filter comes into place. Your biometric authentication posture check is all good. You run through your policies, but then you try and access an unauthorized URL. That's why a web filter feature for remote access is a key component. You want to make sure that those unauthorized URLs are always restricted and users cannot access those. Not only that, but it should be easily configurable to update that list and revoke URLs as needed. Another example would be a policy change. So you may have a particular policy in place where an authorized user, they've done their MFA, they've got their posture check, they haven't done anything else wrong. There's no URLs they shouldn't be accessing being accessed. Their traffic looks good, but they have to have a certain set of compliance met before they can get access to, let's say, a particular sensitive server farm. In that case, if they do something to violate that policy, you want to be able to restrict access or deny access to that particular resource. So and that has to happen not only during the initial connection to know what policy they match on, but if there's a key factor that changes. So if there's something they need to be doing, whether it have up-to-date antivirus or OS updates, or they have to have a particular application running, or they have a prohibited application that should not be running while they're connected to this resource, that can actually change what policy you match on. And if that happens, you need to have that real-time capability to deny that resource. And here's another example. This is our last example here. So everything else is in order here. All the authentication, posture, policies, URLs are all good. But there's something happening on that endpoint that has been analyzed during the network traffic analysis that has been deemed that it's problematic. And so therefore, what you can do, even though they may be connected and authenticated, you can deny access to all internal resources past the gateway. So the real key here for all of these scenarios is in this resource column. You, these can be anywhere. So whatever solution you're looking at, this database, these files, the web server, the servers, the VMs, whatever the case may be, whatever solution you have in place needs to be able to protect these resources and apply very granular access to these resources based on least privilege. And it shouldn't matter if this resource is on-prem. It shouldn't matter if this resource is in a public cloud. It shouldn't matter if it's in AWS, Azure, Google Cloud. It shouldn't matter if it's in your own private cloud. It shouldn't matter if half of these resources are in one cloud, half are in the other, or on-prem. Whatever solution you have needs to be able to address this. And that's what we're finding is one of the biggest challenges is not only from a network access control standpoint, have people had to look, at their solutions and see if what they use to protect their internal networks 2 years ago still can protect their internal networks, but the remote access piece has also gone through a huge shift. And so whatever solution you pick, there's some very minimum standards that need to happen. So the biometric MFA, some form of MFA, but preferably biometric MFA, posture checking, web filtering, traffic analysis, being able to do zero trust, being able to provide least privilege, being able to control access regardless of the destination and regardless of where someone is sitting when they're doing their work. Those all need to be part of whatever solution you choose. So at that point, I want to pause. Looks like it's been roughly 25 minutes. So as promised, wasn't too long of a webinar, but if there's any questions, I'd be happy to entertain those questions.
Brett, there's a questions in the chat. Can you please define posture check? What does it mean? And more importantly, how is the check carried out?
That's a very good question. So posture check basically means the security posture of the endpoint. So it'll mean something different from your organization than it may mean to another organization. It's basically a list, and every product will have its own way of doing this. So for example, the Genians ZTna client, there's over 60 plugins that run on that client that allow you to check various things on the endpoint. It could be related to hardware on the endpoint. It could be related to software on the endpoint. It could be related to applications or processes that are running on the endpoint, file shares. It could be related to if there's a USB, a thumb drive plugged in, peripherals that are attached. So there's really any number of things that you can check. But the main point is that your organization makes a decision on the security policies, the minimum security requirements that a laptop, for example, has to meet to gain access to your network. So that's what the posture check is. Um, each client may have its own way of doing it, but typically what that means is there is a client installed in the endpoint and it's checking things. It's checking permissions, registry, files, applications, traffic. Um, so that's really how that happens is through the actual client, and then the client will report up to whatever the policy engine or the gateway and say this particular endpoint does not pass that test that you've the minimum set of requirements, and because of that it won't gain access. So that's sort of how the process works behind the scenes.
Thanks, Brett. Another question came in. Without split tunnel, will video call traffic negatively be affected?
Well, I mean, you are going to be routing all traffic. So obviously, the connection that you're going to have is going to go through the gateway. So your gateway does have to be sized accordingly because you are going to be passing traffic through it. That's the other thing that makes being able to deploy something virtually advantageous over having to pick an appliance. Because with appliances as a gateway, you're really tied. If you don't do your homework properly and your appliance is not sized properly, now you have to swap out hardware or upgrade or something. When you have a virtually deployed cloud gateway, like with the Genian ZTna cloud gateway, you actually can size it yourself and you can adjust the size. So you can, for example, on AWS Marketplace, you pick a particular virtual machine size, you can size that accordingly. But just like with SASE solutions today, for example, will push traffic through a particular entry point into the edge. So the advantageous part of these solutions is that you get 100% visibility and control. But of course, the downside is with all of those solutions is you are pushing traffic through a gateway. But as long as you size it accordingly, it shouldn't be a problem.
Thanks. Another question is about the posture check. So what are some examples of a minimum posture check requirements?
Yeah. So because we had two questions that were similar, some of those were addressed, but I'll just give you an example. Let's say that you don't want to have a particular application running while they're connected. So let's say something like Skype or something like that. Your ZTNA client can check the process table for any unauthorized applications. And if that application is running, that can be reported, and that could cause you to fail a posture check. Another one could be, specific to having all of your updates or something very basic. Are all of your Windows updates applied? Do you have your antivirus installed? Is it running? Is it up to date? So something even basic as that. And then you can even do something custom. So with our ZTna client, for example, it supports PowerShell scripts. So you can write your own check, basically. You don't have to pick from the 60 we have. You can actually write your own PowerShell script and say, check this, right? And if that check doesn't pass, then you also wouldn't get connected. So there's really a limitless amount of things you could check. It just depends on how thorough you want to be.
Great, thanks, Brett. We'll just give our attendees a quick minute to see if there are other questions. There's one question. How can you stop the user from access 365 directly rather than only through ZTna?
Right. So what happens with the always on functionality? All of your traffic is going to be routed through the gateway. So when with inside of your policy engine, you have the ability to authorize or not authorize, and you can do it a couple different ways. You could do it through a policy, or you could actually filter out a particular URL. So it really just depends on how you configure those policies. But the point of the always on and the point of having the gateway is it's a gateway to anything. So anything that they're trying to access, that's a key example. Is if it's cloud hosted, right, or it doesn't even have to be on your cloud, but if you're trying to access anything, it has to go through the gateway. So you would authorize, and you could do that based on a subset of conditions. So you could say these users are allowed to access that URL, or these other users are not allowed to access the URL, or this user is only allowed to access the URL if they meet these, X amount of other conditions.